So we'll be done in 15 minutes, but I do have 200 slides, so I think I beat the last one just.
Yeah, I mean, you did up to 5 minutes, so you're like, slide ratio was way down.
So don't blink. All right, we're going to talk about the very basics of OOP, so Object-Orientated Programming. When I say basics, I mean anyone that writes code and does anything with objects, it's already over, like, you're way past. But that's all right. So, what is Object-Orientated Programming? Objects are like people, living, breathing things that have knowledge inside of them about how they do things and have memory inside them so they can remember things. We interact with them, told you it was basic, at a high level of abstraction. It's okay, I know you're all thinking right now, super complex stuff, right? Here's an example. By the way, that was how Steve Jobs actually described object-oriented programming back in the 90s when he basically started using it at Next. So that was his definition as part of a Rolling Stones interview.
I'm pretty sure he invented
it. All right.
No, that was Al Gore.
Hi everyone. So I'm a person. Oh my god, what a surprise. All right, this is me. My name is Daniel Draper. My hair color is reddish. My eyes are blue. Size of my nose, average. I talk a lot through my mouth, of course. It's my date of birth. It's important. I work at Interactive. I code in Ruby. Speak English. I live in Australia. I have emotions. These things will make sense later. And so much more. I'm an object. But wait, we have to go back. So I said I'm a person. In programming, we can represent objects like people as a class, which we spoke to see in Rob's where we were generating models. You are all instances of class. The person class knows things, unlike clones. They allow you to have a personality, complexities hidden within, like a name, hair color, eye color, nose size. But we need more examples. Alright, imagine we have another object, a laundry object. You can give it your dirty clothes. You can send it a message that says, can you get my clothes laundered? The laundry object knows things like the best laundry in Australia. It speaks English. It has cash. Knows how to hail an Uber. Knows how to tell the driver where to go. Gets your clothes cleaned. Jumps back in an Uber. Tells the Uber driver where to go again. And you get your clothes back nice and clean. All while you have no idea how the laundry object actually did those things. Because magic. And it doesn't matter. You can speak French, have no cash, don't know how to hail an Uber. But that's okay, because the laundry knows the complexity, because it was all hidden inside. And we interacted with that laundry object at a high level. We basically sent it a message and said, do this thing, and it did it for us, and we don't care how it did it. That's what objects are. They encapsulate complexity, and they interface to that complexity at a high level. Objects collaborate to solve problems. So a person interacted with a laundry, which interacted with an Uber object, money object, and a business object in the last example. They communicated by passing messages, not using carrier pigeons. They basically means calling a method. So for example, we have the person, they called the laundry object and said, clean my dirty clothes, and dirty clothes being another object. So laundry exposed a simple interface called clean, and it takes dirty clothes as an object or an argument. The person knows about this and calls this method to get clean clothes without knowing how that actually happens. Okay. Does this make sense?
Yes.
Alright, or are some of you feeling a little bit like this? Okay. Alright, we'll move on, we'll keep going. So we're going to talk about encapsulation, which we've kind of already touched on without actually mentioning the words. Basically, this means the inclusion of attributes or properties like birthday, which we spoke about, and methods or functions like clean our laundry. So an object will only include, or should only include, the things that it requires to function correctly. Encapsulation is different from abstraction, but they're they're two things that you should probably learn about. So all these concepts we're introducing, you'll need to go home and research more. I'm not going to tell you too much about them. Abstract is where only relevant details are made available and unnecessary details are hidden inside the object. So for example, consider a mobile phone. So the user knows how to about buttons and to push on the buttons, and they know they can touch them. But what happens when you push on the button? It's abstracted, it's hidden away, we don't actually know. It just does things. You touch on the screen, you say, give me this thing, it does it. So moving right along. Inheritance is a way of organizing classes or objects and expressing relationships. This allows classes to define things once and share them with child classes. So we've seen this with Rob's example with the active model stuff, where we had a class name and it inherited from an application record. An application record inherited from active record base. So child classes can then extend these commonalities. Let's take a look at an example. So in this case we have a person, and as someone pointed out to me, students aren't people. Okay, so if you're a student, sorry, not a person. But we have a base class, which is person, and we have an employee and a student in this example. So they're going to share name and address, but employee is going to introduce company and salary as separate fields, and student's going to introduce a school. And shit can get crazy real fast. So this is a pretty simple example, but there's many ways to skin a cat. This was the most complicated I could find on the internet. So, but that's not a today problem. We'll talk about that another day. So what do you get from OOP? Reuse of code and common building blocks, improved productivity, improved maintainability, and better quality software overall. Encapsulation. But what about some of the disadvantages? So the concepts of OOP can be difficult to learn. Code bases can be larger and slower, but it's not really a big issue for today, depending on what you're building. Because we can get more storage, we can get more RAM, and we can get more cores. But as I said, it really depends on the type of problem you're solving as well. Hardware is cheaper than developers in most cases. So let's recap, and this time we'll actually have a look at some code. They are screenshots. I told you I'm not live coding. So I have objects. So we spoke about a person. This is a really basic example of a person. Okay. So we're defining that they have a name, birthday, eye color, and hair color attributes. We can create an instance, like myself. So I'm a person, I have a name, birthday, eye color, and hair color. We can interact with our instance. So here we're going to have a method that says say. When we instantiate and create a new person, we don't care how we say something, we just want it to say something. So basically when we asked the class to say something, it went away, communicated with the brain, spoke to the voice box, spoke to the mouth, everything else in between, and out came the words, hello world. Okay. But we don't care how that happened, we just asked it to say something. And we'll have a look at encapsulation. So this time we have the same person class. I've removed some of the other attributes to make this a bit easier to look at. We just have a name. In this case, when we instantiate a new instance of our class person, we pass in the name, and then anyone can just go and call .name and change our name, which is really not cool, because I like my name. So that makes me sad. So how can we prevent this from happening? First thing, don't use Ruby, because you can do anything with it. But if you're going to follow some practices, this is one example that you could use. So it's a little bit more complicated. So we still have our class person, we still have a name, but you'll notice this time instead of being attribute accessor, it is a reader, which means that it can't be accessed from the outside world easily. When we instantiate or create a new copy of person, we're going to give it a name. But then instead of being able to call .name on person, you'd get an error and it would say the method doesn't exist. So we would have to use this new method we've created called change name and pass it the new name. So there'd be some fancy code in this, name change approved. So we'd go off, we'd check birth certificates and marriages or validated driver's license or whatever else we want to do that's crazy to make sure that the person that's trying to change the name has permission to do that. And then yeah, that's it. So nice and simple. And then we'll check out inheritance. So we spoke about student earlier. So this example here, we have a person and we have student. So again, we're going back to the basics. So we have a person, we have a student, we see the little bracket, the little angle arrow there. What's the technical name? Chevron, there we go. And it inherits from person. So what this gives us is name and address from person, and it gives us the school from the student. So when we call the student object, we get all the things that are in person as well in this example. Does that make sense? Cool. Now, let's combine all the things. So this is a quick look at, again, there's many ways to do this, but in order to demonstrate all the things we've spoken about, this is an example of how it could look. We've spoken about with our name change, so this ensures that we are the only ones who can change it. We've hidden away this method called name change approved because no one else needs to know about it. It's purely for us internally to use to see whether we're allowed to change the name or not. We then inherit the person for student, and then we can we can change the name at the point there of initialization, or set the name, sorry, and define the school, and that's it again. Whatever you call on student, if it doesn't exist on student, like change name, it then goes and looks at person to see if the method's there and calls it there. That's it, literally. 5 minutes. Any questions? Yes?
Overriding methods and descendant classes.
Yes, you can do that.
You just define a method with the same...
Same name and same signature. So like we could, in student, we could have change name with like just a string that's accepted as well, and put what we like in there. Yeah. And then if you wanted to call back to like the person, you would call like super, and it would call a parent method.
And when you change it to a reader attribute like that, it means you can't assign to the dot name. Do you still read from the name the same way?
Yes. So you can still read from the name, but you can't access it outside of like in an instance of a class.
Okay, so you can't.
So you can't go like person1 dot name equals, but you can go dot name to read that or to display that. Yeah.
What was the private doing above?
Yeah, so that was that's basically like abstracting away or hiding that method. So from the outside world, if we had person1 as an instance of person, you wouldn't be able to call that method. So if we go back,
So that'll hide the one method that's...
Yep, so the one, anything below that private, so that's like just a keyword, and then anything below that will not be available to the outside world. So we could go person1 dot name change approved, and it would be like method undefined. But when I said about Ruby, you can do all the things. I'm not joking. You can just go like .send, which don't ever do this. But you could go .send, and you could call that private method, and it would let you, because Ruby's powerful like that. So yeah, you know, but it's a very intentional like action if you're using something like public send or send. So generally speaking, the idea is that it hides it away, so that because we don't need it in the outside world. Like that method is purely to see whether we have permission to change a name or not. It's not a method that we're going to call on its own outside. It doesn't make sense on its own. So it's intended to be called with something else. So we hide it away and we use it inside the class, but we don't want anyone else to call on it. Does that answer your question?
Yeah. Could you just make it a constant?
You could, but like in this example, we would potentially have it call out to another class maybe and do some other things like, you know, look up births, deaths, and marriages to see if your name change has actually been registered or whatever it might be. So yeah, it depends on what you're doing. Yeah. I just didn't want to write the code to integrate with any government stuff.
Is there protected or abstract methods?
Yeah, so you've got private, protected. What else is there? I don't think there's any others.
That's going to.
Yeah. So yeah, you've got protected and private. So private is like purely within like the class, so within person, and protected would be allowed to be used by inherited objects. So you'd be able to use it inside a student. I believe that's correct.
What about abstract and static methods?
No. There are, so static methods can be defined, I suppose, in a sense where you can go self-dot in the method signature. So in here we could have, not that it would make sense, but we could have self-dot change name. And so what that would allow you to do is call like person dot change name. but because we don't have an instance of a person, there's no name set, and so it doesn't really make sense. But that's probably the closest thing you get to a static method in Ruby, and there's no really abstract methods because you can override whatever you like and do what you like. So everything's abstract in Ruby.
There's patterns for kind of doing abstract things.
Yeah, yeah.
I like the way it does that private there, because like in some other languages like TypeScript or C#, I don't know about C# actually, but in TypeScript, if you define a private method at the top, it'll say private methods should go at the end.
Yeah, so you can put private kind of wherever. Generally, what you'll find is it goes at the bottom because any other method you put beneath that private keyword will be private.
So basically everything from there down
Yes,
to private.
it's private.
It's actually a public.
Yeah, so you can go back to public. But, and there's also other people I've seen where they put like private in front of the def, so it'd be like private def method name. You know, yeah, coding style is up to you.
And does that do it just for that method, or will that do it for everything?
It's still all the way down, I believe.
Okay.
So until you define public again or protected.
We just do it in front of every method, in front of every public.
If you really want, just write on that.
Yeah. So I mean, you can do whatever you want, but the pattern is going to be often that.
Yeah.
Like if you are having private methods, you put them at the bottom.
Yeah. Yeah. That's right. Any other questions?
Yeah, what does send do?
It basically opens up the class again at like a very low level, and it sends that like class name, the method name to the object, and if it responds to it, it displays the results. If not, it does nothing. But the internals of it, I'm not quite sure. I just know that it's a very bad and evil thing because you can do some very bad and evil things with it.
Is it like considered to be bad practice to create a setter for it, like def name equals, and then be setting it like that because that could then throw an error? Like, is that why you chose change name, or?
It was more just for like sake of example.
Oh, okay.
Yeah, you could have had like a setter defined and done the same thing, but yeah, it was more just to make it like move away from getters and setters and make it clear that, you know, what we're doing. Yeah.
This is probably a really dumb question. Is this like white space sensitive?
No. So you kind of have some really funky flexibility. Like you can put code on new, so like where we've got @name equals, we could stick that new underscore name on a new line and Ruby wouldn't care. It'd just be like, sure, I know what you want. So there's a few exceptions to that, but generally speaking, white space is not a problem.
What's the question mark after that? Name change approved?
It's a bit of a nicety in Ruby, a bit of a pattern, common pattern. So basically, the intention is that you're going to get a Boolean response back, so a yes or a no, or true or false. It doesn't really give any special powers or anything, so it doesn't like force a Boolean to be returned or anything. The idea is that when you write Ruby, you should be able to write Ruby like you would read English, and so by having the question mark allows you to, you know, write a method that really clearly explains its intent. So yeah, as far as I'm aware, there's no special powers with it. It's an allowed string character.
So the only reason you'd be writing that is clearly from a developer readability standpoint.
Yeah. Yeah. So it's purely for like the convention is that if your method returns a Boolean, then you would have a question mark. But if it doesn't return a Boolean, like our change name, then you just have nothing at the end there.
Like in Java, you instead of having that, they use everything.
That's right. Yeah.
Whereas they got rid of the use
And we
concept.
do a question mark. Yeah.
And is there like a JavaScript truthiness kind of typecasting? Like if you return 1, would it?
Yeah, so you can use, and it does depend on the objects that you're working with, but you can use exclamation, and it will guarantee a Boolean like response back. So like it will convert any object. So Ruby has like a true or a false for a lot of different things. So like it will nil and zeros and ones and yeses and nos. And when you use exclamation, it'll convert the response to a Boolean if it can, and then whatever the response is, it converts that to a guaranteed Boolean. So if it gets back some weird like string, it'll return false. So because it'll basically result in nil, which will be false. So it's probably maybe the closest thing. I don't know if anyone else. more Ruby experience has any other?
Just probably just to redefine that, Ruby only has two falsies.
Yeah.
That's nil and false.
Yeah.
And everything else is true.
Yeah.
It doesn't matter what you said. 0, empty string, any of those things is all still true.
Yeah.
So unlike a couple other languages out there, everyone's got their own definition.
Yeah.
All sorts of cool nonsense in.
Yep.
So, but it is good to use the double exclamation.
Yeah.
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 If that name change approved method is protected, can I call it from outside?
So you could call it from like within the student class, but you would still, and it depends. So, for example, when you're talking about a controller where you have protected method, you can call that in a view, which is like kind of outside, I guess, to a degree. So it gets really confusing. But when you're talking about just like plain classes, protected should only be able to be called by like inherited in classes. Yeah. So yeah, Ruby like views allow you to do some things that you probably shouldn't be able to do, but there you go.
No.
No.
They don't do anything wrong.
It's the standard developers. Anything else? Cool.
Alright, thanks very much.